We're going to be exploring more about logs, graphing, and creating equations from a graph. So just refresh a couple of things: the parent function, the common log, and the natural log, what those are, and then what our transformation formula would look like. So y, we know we could write as f of x. If we have a plus or minus in front of the log, a number there, that can change the vertical stretch or compression. That's the vertical stretch or compression factor. And if it's greater than 1, it's a stretch, and less than 1 but not 0, it is a compression. And of course, if it's negative, it reflects across the x-axis. Then the b, of course, is just our base, and a parent function, it's a common log, 10, and we'll talk a little bit more about that. And then if we have a number inside of our parentheses of our argument, a c, that's a horizontal stretch or compression factor. And it is opposite of what we think, so it's opposite of what the vertical does, so make sure you remember that part. Of course, if it's negative, then it is going to reflect across the y-axis. And then the h is actually our vertical asymptote, and it is also our horizontal translation. So if you see a negative, remember what you see is opposite of what you think happens. So if you see a negative, it's actually moving right, and if you see a positive, it's moving left on the x-axis. And then the k is what you see. So if it's positive, it's moving up, and if it's negative, it's moving down. That's a vertical translation. So remember, the exponential and logs are inverse functions and reflect across the y equals x axis. For exponential functions, they have horizontal asymptotes, but for log functions, they have vertical asymptotes, and we write those as x equals whatever number they're at. And again, we can find that in our equation. So we're going to talk about some steps to graphing logs. Step 1, when we're going to graph a log, if I'm giving you an equation, you're going to set x equal to 3 things. The first thing you're going to set is equal to 0, and that's going to be your vertical asymptote. The second thing is to 1, and then the third thing is to its base, whatever its base may be. Then you're going to make a table and find 2 points, not the vertical asymptote, but 2 other points. And then you're going to graph the vertical asymptote first, and then the 2 other points, and connect the dots starting from the asymptote. So we're going to do an example together. So this is our first example. So the first thing that we're going to do is go ahead and set our x equal to those 3 things. So x is going to be equal to 0. X is going to be equal to 1. And then x is going to be equal to our base for our problem. So in this case, 2. Now, we're going to make a table, and something you always have to remember, the log of 1 is always 0, and we'll talk about why that is. But we already know that this here is our vertical asymptote. So in our table, we have x and we have y. I'm not going to worry about the 0, but we'll do the 1 and the 2. So 1, when I put this into this problem, n for x, I would have log base 2 of 1. So if I wanted to solve for what y would be, I could write it as exponential. 2 to what equals 1? Well, that's why we think about when we say 2 to what equals 1, the only thing that can make something equal 1 is either 1 itself or have something raised to the 0 power. That's how we know it's 0. Now, when we put in our 2, we'll do the same thing. Log base 2 of 2, again, exponential 2 to what equals 2. In that case, it's 1. Now, also you can see if you were to look here, if the argument and the base are the same, those cancel out, and this is the same as 1. Now, notice that when we had our vertical asymptote as x equals 0, that's kind of where our parent function takes place. So we'll draw a quick graph here, different color here. So our vertical asymptote is right here at x equals 0. And then we'll go ahead and plot our 2 points. We have 1, 0, and we have 2, 1. Now, we start from our vertical asymptote because we never going to touch that and graph that direction. Okay, just give you a little idea. So then I want you to notice, we know our vertical asymptote, we would write that as x equals 0 is done. And then we want to talk about our domain and our ranges. So our domain and our range are opposite from exponential. And so if we remember what they are in exponential, it'll help us with these. So if we look at domains, we actually here at the asymptote have to start at 0, and 0 is not included. So we use that parentheses, and then it goes on forever. It would continue that direction. So we have a positive infinity. Range, opposite of exponential, goes forever at our negative infinity here, and it actually will continue up, even though it doesn't look like it's going that way. It is, over time, continuing up positively. So this is all real numbers are negative infinity to positive infinity. So here's one that I want you to try. This one's log base 3. X minus 1 plus 2. Notice there's been some things added, transformed here. And so pause the video and then see how you do. All right, so let's take a look at our steps here. So the first thing I did was set x equal to 0. And notice because I have the x minus 1 here, I set the whole x minus 1 equal to 0. And when I solve for that, add 1 to both sides, I get x equals 1, and that is my vertical asymptote. And then I set it again, equal to 1, and then again to my base that I'm given. So I end up with 1, 2, and 4. And there's no reason to put 1 in my table because that's my vertical asymptote. So I use 2 and 4. And then I showed you how to solve those in my table. Of course, you could do that in a calculator or to the side. So when I put in 2 into my problem here, 2 minus 1 gives me 1. This log base 3 of 1 is the same thing as saying 3 to what gives me 1. Well, we again know that 0, and the 0 plus 2 gave me 2. So we end up with 2, 2, and 4, 3. I went ahead and plotted my vertical asymptote first, and then my 2 points, my 2, 2, and my 4, 3. Start from my asymptote and go across, and now it is graphed. I can then talk about my domains. We are at 1, that's my vertical asymptote, not included, and to positive infinity, and then the ranges are all real numbers, negative to positive. I want you to try that one. So you can pause and see how you do. And if we look at this one, we can see, again, we have a little bit different, and notice how it graphs differently. And think about why that would be. So we have this negative value right here in front of our log, and that causes some things to flip. That's why it's always important to try to, when you put your points, to try to do it from the asymptote so you kind of know which way it goes. Of course, that changes our domain. Now we're going from 5 is the highest we can go, and negative infinity is our lowest. So we start at negative infinity going to 5. Now we're going to talk about writing equations from log graphs. So here's some steps and information to know. So basic or parent or common logs go through 1, 0, and they have a vertical asymptote of x equals 0. So this is one that I've done just basic one, and I've got 2 points marked. This is a graph here where I may not know the b, okay? So my general form is y equals log base b of x. So the first thing I want to do is think about converting that general form to exponential form, and that's where I get the b to the y equals x. So I just, base b raised to y around the world equals x. And I'm going to plug in another value that's not the 1, 0, not the x-intercept, and use that to help me solve for b. So I plug in the 1 for the y and the 4 for the x, and then I solve for b. Well, b to the 1 equals 4 is pretty self-explanatory that b is 4, and then I'm going to rewrite the log. So I found that my log is base 4 to the x. Okay. So we're going to do one when it's been transformed. So here is a particular one here, and it has a different x-intercept and then another point. And so we're going to look at this point here. We have this one at 7, 0, and this one we have at 19, 1. So we're going to look at what our transformation would be. When we think about this one, move left or right, normally our point is at 1, 0. So we can't say we're at 7. We have to think about how far did we move from here over to 7. And that is actually 6 spots. Okay, so then our 6 will actually go where our H is, and that's our vertical asymptote. It's approaching 6, but it's never going to touch it. Even though the asymptote's not there, we should be able to realize kind of what's happening because it's a log. So we're going to plug in to our transformation equation what we have, log base b and x minus 6, because we know we moved over from our parent function 6, and we keep that negative because what we see is opposite of what we think is happening. So that means that we moved right 6, not left, even though we see a negative. Now we're going to take this other point we have, this 19,1, and we're going to plug it in for our x and y. So y is going to be replaced with 1, log base b, and then our x is replaced with 19. And we're going to simplify down. Y equals log base b, and then we have 13. And then we will write that as an exponential. So we have the base is b. Of course, that's what we're trying to solve for. And then we're going to do the round the world. So the 1 equals 13. Pretty evident now that b is equal to 13. And now we're going to rewrite our equation. So we have y equals log base 13 and x minus 6. And that would graph the graph above. So that's the equation that matches. So I'm going to give you another one for you to try. So here is one for you to try. Pause the video and then see if you get it right. Look here, and I went ahead and marked my points that I knew, and then I made a mark on where my normal one is to help me. So I know that from where I am here all the way over to where our parent function would be, I have to think about how far I moved. And I actually moved 9. Even though I'm hitting at -8, I start at 1, all the way to -8 would be 9 spots. So my H is 9. And I moved -9. So it ends up making it a positive in my equation. Then I used the other point that I had marked, 0, 2, as the x and y's and solved for b. So then I found that b squared was equal to 9. Remember, we can't have a negative base, so I knew it could only be 3. So log base 3, parentheses, x plus 9.